Hey there guys. Hope everyone's well. Today in O-Level Physics, Lesson 1, Physical Quantities, Units and Measurement. Physics begins by measuring quantities that can be stated as a number and a unit. The SI base quantities used most often here are length in meters, m, mass in kilograms, and time in seconds, s. Derived quantities combine base quantities. Speed has unit m over s, density has unit kilograms m cubed, and force has unit kilograms m over s squared, called the Newton. A bare number is not a complete measurement. Base quantities stand alone. Derived ones are built from them. Speed is length over time. Always expand an unfamiliar unit back into base units when checking dimensions. For example, length is a base quantity. Its unit is the meter. Speed is derived. It is meters per second. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Prefixes make very large and small measurements manageable. Kilo means 1000, centi means 0.01, milli means 0.001, and micro means 0.1. Convert before calculating. 36 cm equals 0.36 m, while 2.5 ms equals 0.0025 s. Prefixes only resize the same unit. Kilo stretches by 1000, milli shrinks by 1000, confuse the direction and your answer is off by a million. Standard form writes 0.00042 as 4.2 times 10 to the power of minus 4. A common mistake is to convert a squared or cubed unit by the unsquared factor. 1 cm cubed is 10 to the power of minus 6 m cubed. For example, 5,600,000 meters is 5.6 times 10 to the power of 6 meters. With kilo, that is 5.6 times 10 to the power of 3 kilometers. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Choose an instrument whose range covers the measurement and whose resolution is sufficiently fine. A meter rule commonly reads to 1 mm. Vernier calipers can measure an internal or external diameter more precisely, and a micrometer screw gauge is suitable for wire thickness. Compare the least counts on each instrument. Smaller least count means finer resolution. That is why a screw gauge beats a meter rule for thin objects. Read a scale at eye level to avoid parallax. For a cylinder, measure several diameters in different directions and average them because the object may not be perfectly circular. For example, a meter rule has least count 1 mm. A Vernier calipers has least count 0.1 mm. Add main scale reading to Vernier division times least count. Align the coincidence carefully. A 1 division slip shifts the answer by a full least count. Precision describes how closely repeated readings agree, whereas accuracy describes closeness to the true value. Random error causes readings to scatter and is reduced by repeats and averaging. A systematic error shifts readings in one direction and is not removed by averaging. If calipers read plus 0.02 cm when closed, the zero error is plus 0.02 cm and the correction is -0.02 cm. Record all raw readings consistently. Timing repeated events improves a small time measurement. Instead of timing one pendulum swing, time 20 complete oscillations, repeat, average, then divide by 20. If 20 oscillations take 32.4 s, the period is 1.62 s. The reaction time uncertainty is then a much smaller fraction of the measured interval. The same repeated measurement idea applies to the thickness of one sheet by measuring a stack. Significant figures communicate justified precision. A result calculated from 2.4 m and 3.15 s should normally not claim 6 significant figures. Speed equals 2.4, all over 3.15 equals 0.76 m over s to two significant figures. In tables, headings contain quantity and unit, such as length centimeters. Always inspect whether an answer is physically reasonable and distinguish a quantity, its symbol, its numerical value, and its unit. For an instrument question, identify the required range and resolution, describe the reading procedure, check for zero error, repeat where useful, and state the corrected mean with a unit. For calculations, convert prefixes first and round only the final answer. A micrometer reads 0.62 mm for a wire and has a plus 0.03 mm zero error. The correction is -0.03 mm, so the corrected diameter is 0.59 mm. Repeating at several positions tests whether the wire is uniform. Do not confuse precision with accuracy. Omit a unit, read a scale from an angle, or average readings before correcting a systematic zero error. Remember that area and volume conversion factors must be squared or cubed. Practice. Convert 3.6 ms to seconds. Answer: 3.6 times 10 to the power of -3s, or 0.0036 s. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. 20 oscillations take 31.6 s, 32.0 s and 31.8 s. Calculate the mean period. Answer: mean time equals 31.8 s, period equals 31.8, all over 20 equals 1.59 s. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Alright, that wraps up physical quantities, units and measurement. Coming up next in O-level physics, motion, speed, acceleration and graphs. Stay curious and see you in the next lesson.